Okay children, today we will study about electric potential due to single point charge. So for that there should be a single charge, say plus Q is a single point charge, okay, and E represents its electric field. That will be in outward direction. For positive it is outward direction, for negative it is inward direction. Now see, plus Q0 is the test charge and Q was source charge. Q0E means it is the force that will be moving in outward direction. It will make this Q test charge move in outward direction because it is repulsive force. P is the point where we have to find electric potential, and XB its distance from plus Q source charge. Now again we are taking another point Q and one more point B. I think we have to find electric potential. We will consider this R point also. Okay. Now see, test charge is at point Q0. Now we will move this test charge to point say Q. That is, displacement will be dx, and what will be if displacement is dx, then and force both are in say in opposite direction, children. So that means again a negative work. So we have to do work to move this test charge to point Q. So we will find out work done to move this test charge from P to Q, and then we will integrate and we will find out work done in moving a test charge from infinity to point B, because then we will be able to find potential at this point B. Okay, so see, plus Q0 with the test charge at a distance P, and which is at a distance x from source charge as written in this slide. Now this plus Q0 is moving in outward direction as already explained. Now one more thing you should remember, that we when we do work, we don't have to do overwork. That means we don't have to apply force. So we don't have to we have to prevent acceleration. Only that much amount of force is to be given, which is equivalent to repulsive force, which is equivalent to this repulsive force. No extra force is to be applied. There should be no more acceleration to it. Only just to balance this, we have to move that much amount of work is to be done. So to prevent this acceleration, equal and opposite force minus Q0E has to be applied on the test charge. Now, so the work done we can find as F dot dx. It is the dot product. Again, work is a scalar quantity. You can write Q0E dot dx, or you can write d cos 180, that is minus. So that is negative work. Now this E, electric field, formula is 1 upon 4 pi epsilon 0 Q upon x square. Why Q? Q because this electric field is of this charge plus Q, and x is the distance of point P from point plus Q charge. So this is the small amount of work done. Okay. Now total work done in order to bring a test charge from infinity to point R. This R is our reference point. We have to find electric potential due to this plus Q charge at point B, that is at distance R. So our strategy was to find small work done to move it from P to Q and then integrate it for infinity to R. So we can write integration sign from infinity to point B or infinity to R formula, and then we can, because Q0 4 pi epsilon 0 x square, this x square should be inward and this x square is should be deleted, it should not be there. I think it is wrongly written here. So it will be from infinity to R 1 by x square dx. Now integration, of 1 by x square is minus 1 by x. Already in 11th class I have taught you how to integrate. You can write x square. See, I am telling you by means of a pen, using pen. It can be written, I am writing it here, please pay attention, only that much, x to the power minus 2. See here, minus 2 dx. Here dx means we have to integrate with respect to x. So minus 2 means x to the power minus 2 plus 1. Okay, why formula you remember, n plus 1 upon n plus 1, that is again here also it will come minus 1, minus 2 plus 1. So your answer will be x to the power minus 1 upon minus 1, or you can say minus 1 by x. So minus 1 by x. When it is inside the integration sign, you have to write limit over here. It comes like this. See, infinity here, r here, and minus sign can be moved outward and it will become plus, and you will have this value 1 by x. So when you will keep the limits, you will get 1 by r minus 1 by infinity, 1 by r minus 1 by infinity. 1 upon 4 pi epsilon 0 q0 will remain same, and along with that you will get this much, 1 upon r minus 1 by infinity. 1 by infinity is 0, so answer will be 1 by r. So your final answer. Now again arrow portion. So see here, formula becomes V is equal to Q upon 4 pi. Now see, here work done was Q0. Now work done per unit test charge. The definition of potential or the formula of potential is work per unit test charge. So work from infinity to B per unit test charge. So this Q0 can be brought in denominator. You will get Q upon 4 pi epsilon 0 R. This is the formula for potential at a point B, at any point. It is inversely proportional to R. So as R increases, the potential decreases. So potential at Q is more than potential at P. Potential at B is more than potential at P. So as we move towards the source charge, potential increases. So therefore we have taken at infinity potential is 0. I think this much is clear to you. Now our next is electric potential due to group of points. There are so many charges, not unknown single charges. We have just now studied potential due to single charge. Now we have to study potential due to number of charges. Nothing is difficult in it. You can add it. Algebraic you can add. If there is positive charge, plus V. If there is negative charge, minus V. See here in the diagram, there is one point P, plus 1 coulomb is charge is there. Q1 another charge, Q2 another charge, Q3 another charge, Q4 another, Qn. There are number of charges which are at a distance R1, R2, R3, R4. Say similarly Rn. At P we have taken a test charge which is plus 1 coulomb. So the potential, so the total potential we can write, say at point Q1 at a distance R will be V1. Again here V2, V3. So the because in a scalar, because potential is a scalar quantity, so it is easy to add. If had it would be in this vector, then we have to take into various laws of vector addition. So here it is a scalar quantity, so you can have a algebraic sum and you can find out the total potential. See, V is 1 upon 4 pi, epsilon 0 can be common. This is summation sign, Q upon R1. That is for V1 it will be, I will tell you how to write it. Say V1, I will tell you. V1, you can write V1 as, V1 is equal to 1 upon this 1 upon 4 pi epsilon 0, and this can be written as Q upon, see this thing, I should rub this. This is epsilon 0 and this will be Q. Can I have Q upon R1. Similarly for V2 it will be same thing will be there, but it will be Q upon R2. Had it been minus charge, then you would have written minus Q3 upon R3, minus Q4 upon R. So you have to take sign into consideration over here. While doing numericals also you have to take sign into consideration. This is according to position vector. So you can see electric potential at a point due to a charge is not affected by the presence of other charges. Secondly, potential is inversely proportional to R, whereas Coulomb force, it is inversely proportional to 1 by R square. Potential is scalar, whereas force is vector. V is called potential at a point. Okay. Now next is, before doing this, you already know what is electric dipole. Now we will find electric potential due to electric dipole. Now first we will find at an axial. Very easy, because you have already determined at an axial electric field. Similarly is potential. It is easier than electric field. See here, there is dipole minus q plus q. Children, remember, here you are taking minus q and then plus q. In any exam or when you are writing, sometimes we write here plus q and minus. That is also correct, but you should be very clear about the direction of electric field, as well as, because when you find out the net electric field, the direction may change when you change the this configuration of this dipole. If you take plus q, here minus q, there your direction of electric field will change. But when you take minus q, we are doing here as minus q we have taken in first order and plus q in second. P is the dipole moment from negative to positive. Okay, 2L is the length of the dipole. P is the point where we have to find electric potential. Plus 1 coulomb, that is test charge, very small charge. And let P, this where we have to find electric potential, we are considering this point at a distance x from the center of the dipole. Remember this is from the center of the dipole, P point. Okay, now V1 we will take due to plus q charge. This plus q charge means, children, this plus q charge, here it has been written plus q. That plus q means due to this plus q. Potential due to this means you have to take this much distance into consideration. That is x minus L. So here x minus L. Formula is 1 upon 4 pi epsilon 0 q upon x minus L. Okay, q by r, it was r means the distance of that source charge and the point. So here the distance is x minus L. Now for the next, we will take due to minus q, due to this minus q, it will be x plus L. See here in the numerator they have taken minus q. Because why we have taken minus q? Because v is a scalar quantity. Why? V is a scalar quantity. Okay, now next is total potential, will be addition of these two. Just now we have studied electric potential due to multiple charges, so this will be mere addition of the two. So when we add, we take q upon 4 pi epsilon 0 common, 1 upon x minus L minus 1 upon y minus, because there is minus sign over here. Then we solve, you will get this much. In place of q dot 2L you can write P, which is dipole. So potential is P upon x square minus. Got it, children? Very easy. Now next is at an equatorial point. Equatorial line is the perpendicular line passing through the axis of dipole. Again, electric dipole minus q plus q, 2L distance, P is the electric dipole moment from negative to positive, O is the center of the dipole. Now let q be the point where we have to find out potential due to electric dipole. Let y be its distance from the center of the dipole. And we have joined this line. These are imaginary lines, just joined it, because at point q you have to find potential due to minus q, at point q you have to find potential due to plus q. So we need this distance. We can use Pythagoras theorem. This y and L can be used. Theta be the angle which dipole makes with these lines. See, due to plus q charge, it will be 1 upon 4 pi epsilon 0 q, the charge bq. Q is this much charge, bq is this distance. Again for negative it will be distance aq. Here again minus q has been taken. Children, remember, sign you have to take in scalar quantity. Total potential will be 1 upon 4 pi epsilon 0, q common 1 upon bq minus 1 upon aq. What is bq and aq? Both distance are same. You can find using Pythagoras also. Y square plus L square under root, because they are equal. So potential at the equatorial position of an electric dipole is 0. See here children, this question comes in board examination. Signify or explain the condition where electric field is there but electric potential is 0. So this is one of the condition. In case of electric dipole at equatorial position, electric potential is 0 but there is electric field. Okay, so this question is very important. Okay, thank you so much.